test for Monday. The test chapter 1. Monday.
This chapter 1.
Yeah, Monday.
What about it?
The test. Or Wednesday.
Wednesday. Check your syllabus. Check your syllabus. All right.
Tuesday.
Wednesday. I don't see you on Tuesday. Okay. So guys, we just kind of covered units again. So back to units. Again, remember, every time we're dealing with numbers, they have to have a numerical value. You know, you cannot put a standalone number because, you know, it leaves ambiguity. It leaves uncertainty. We don't know what that number means, okay? So for a number to be understood, it needs a unit. We already talked about the units of length, you know, distance, circumference, and feet. Guys, I'm gonna send you this presentation in a PDF format this afternoon, okay? And we know the units of area, squared, and we know the units of volume are cubed, okay? Just kind of doing a refresher because I was kind of just going off the dome the other day. All right, so a little continuation. Always use fundamentally correct units, meaning that if we're doing a unit for length, definitely don't put a unit for volume after that. You know, so you know, like us, we usually tend to use centimeters and here in ultrasound. But if you ever look on your synapse, when you're looking at your image on synapse, they actually use millimeters. If you happen to pull up the ruler on synapse, it actually measures stuff in millimeters. So we're going to talk about that unit conversion, how to convert centimeters to meters today, or centimeters to millimeters today. All right. So we talked about increasing by a factor just means multiplying by a number. Decreasing by a factor means to divide by that same number. Okay. Percent, guys, that's a unitless number. Okay. It's a unitless. It doesn't have a unit. Okay. Percent is just a number or a ratio as a fraction of 100. All right. So, for example, 6% is actually 6 over 100 or 0.06. Okay. So it's not necessarily a unit. Okay. It's just a shortened version to describe a fraction or a decimal.
So the question is in the homework for the unit of percentage. So just put unit.
It's units. Yeah. Hey, sometimes I come with that left hook, but you don't even see it coming. That trick question. So just be aware. Just be aware. Okay. But yeah, that's supposed to be a unit. Unitless. Okay, because percent is not a unit. All right. So it is important to know how to convert from one unit to another. Guys, I love that purple box. That's on a purple box right here. When units change, the total picture doesn't change, only the manner of presentation. So no matter if you have 4 quarters, 20 nickels, 10 dimes, 100 pennies, they all equal $1, right? So the total picture doesn't change because they equal the same amount, just the units are changing, right? So they all represent the same thing, okay? So powers of 10. So know that scientific notation is an engineering notation or synonyms. Okay, so I may use them interchangeably. Okay, scientific notation is a shorthand manner to represent very large or very small numbers to make them more digestible or more easier for us to understand. Okay, so some rules of scientific notation would be a number with a positive exponent will have a value greater than 10. So if we have the number 100, that's going to be a positive exponent. If we have a number that's less than 1, then that's going to be a negative exponent. Okay. So for example, on our positive exponent, this number 1 million in scientific notation should be written 1.0 times 10 to the 6. Basically, when you have all zeros, those numbers are easy to convert because you can basically just count up the number of zeros or the digits. I'm coming to you. You want to know how to do that, right? We're coming to it. We're coming to
the bottom one. I can never.
The bottom one. So, so with the negative number, 1.24. So when you're doing the powers of 10, we're gonna get to the rules right here. Bang. So when we're doing a power of 10, you have to do 2 things. You have to move the decimal point so that the resulting number is between 1 and 10, because that's what scientific notation is. Remember, we're trying to make the number easy to understand, right? Or not only just between 1 and 10, just move it to where 1 unit is to the left of the decimal, right? I mean, 1 number is to the left of the decimal. See how scientific notation, 1 number is to the left of the decimal, right there, okay? So that's one way you can do it right there. And then you have to multiply the appropriate power of 10. So for example, with scientific notation, 213 million right here, that's a big number, right? So we're gonna start at the end of this whole number. We're gonna move, we wanna make this number so it's between 1 and 10. So we're gonna move our decimal point in between the two, because we can't move it to we can't make it 21 because that's bigger than 10. We can't make it 0.2 because that's lower than 1. So we have to stay between 1 and 10, right? So we got a whole number right here. We're actually gonna move our decimal however many times to make it between 1 and 10. So that would be, you can just count the numbers. 1,
So the
2,
decimal is before,
3.
after the zero.
What?
The decimal is after the zero, right?
The
So
decimal is after the zero?
No, sorry, like.
Yeah, it's a whole number.
Yeah,
It's
so-
a whole number. I can't change that. It's a whole number. So yeah, I'm gonna have to move that decimal back so I can make it a number between 1 and 10. So that's moving in 8 spaces. So 1, 2, 3, 4, 5, 6, 7, 8. So I would actually write this number 2.13 times 10 to the 8th power. Okay? But just like I can make a number in scientific notation, I can also put it back in expanded format, right? So just like I have 5.6 times 10 to the 4th, that means that I need to move this number back because it's a positive exponent. So we know that that number is going to be larger than 10, right? So I'm going to move my decimal to however many numbers the exponent says. So move it over, 5.6, 1, 2, 3, 4. 56,000. So just like I can do them both ways, I can make it in scientific notation, and I can turn it back into expanded form. Okay, let's do it again. Right here, we have a number less than 1, right? This number is less than 1. So again, we need to make this number so where the number is still between 1 and 10. So to do that, we're gonna have to move our decimal point in between the 8 and the 7, correct? Remember I said I need one number to the left of the decimal, okay? Or just make your number between 1 and 10. So I'm gonna move the decimal, how many spaces? 1, 2, 3 spaces to make that number in between 8.72. That's between 1 and 10, correct? So to write that in scientific notation would be 8.72 times 10 to the negative third, because I went from a smaller number to make it a larger number. You see what I'm saying? Because that number is less than 1, I know my exponent is going to be in the negative. We're good there? Resounding, shaking heads? Okay. And again, you can always change that number back in expanded form. Okay. You guys want to do some practice questions, or are we good? We understand? Let's do a few practice questions, man. I'm just going to throw some random numbers patterns. You volunteered, but I ain't going to step up. So, matter of fact, let's just look at the homework, guys. You guys had the homework, right?
Yeah.
All right. So, man, let's do this. I like actually doing the homework within class so we can make sure everybody understands. I want everybody to get a 100 on the homework. That's the goal. All right. Lauren, I'm gonna get you up here as well, okay? And guys, if I call you to the board, it's really not to pick on you. I'm never gonna try to pick on somebody. I really just want to make sure everybody has that understanding, okay? Okay, you ready?
Yeah.
Don't look at your homework. Did you already know the answer?
Oh.
Come on up here. Come on up here. 1, 0, 0, 7, 8. Guys, I messed up on the homework. I think I made it so you guys. I think I left off the number 8 on the homework. I think I accidentally deleted that, right? But it's all good because I know I made that mistake. So we have.
So you want us to add the line there?
No. Keep it the way it is. Keep it the way it is. I've already adjusted for it.
Yeah, can you just?
Let us try by ourselves first.
My answer was 5.6.
But how did you get it?
I'll give it to you.
How did you get it? That's why I say don't look at your homework. Don't look at your
Yeah,
homework.
but this is the answer I got, but this is how I got the answer by moving the decimal point from the end towards the right. So
Go ahead and put our little humps under
So
there so
I'm
we
gonna
can
put my,
count.
so I'm gonna go 1, 2, 3, 4, 5, 6, 7, 8, 9.
Because
So that
5.6 is
decimal's gonna
between
come
1 and 10.
5.6. So since it's, you're going to the right, it's gonna be a negative 9.
Good folks, good folks. Lauren, what's up? Let's go. Let's do the next two. Let's do the next two. Do the next two. Oh, no, use that red pen. Use that red pen. I want you to work it out first. So already just eyeball and see where can I put a decimal that's gonna make that between. Okay. Okay. So what are you gonna do?
Do you know?
I don't know why you looking at hers. You got to work out your problem yourself. So how did you get that? How did you just gonna put the decimal there? How did you get it there?
Because you said we have to keep this number
Right.
between 1 and 10.
But you have to start with the end of the whole number. So
Oh.
that's how you know what your exponent is
Oh,
by how many
okay.
times you move the decimal.
Okay.
So there
Okay.
you go.
Two.
There we go.
And then
Can I
what?
say something?
Go ahead.
The reason, here usually there's the decimal and then 0, 0. So we don't show because we're supposed to know automatically.
Automatic.
So yeah, that's why we're moving from here to there. But because,
Right, I'm not gonna
Yeah,
put,
so
we
that- some
understand that that's a
people
whole
get- yeah,
number.
some
We
people
understand that
don't
that's a
get it.
whole number.
yeah.
So we don't wanna add extra numbers, but if that's the way
Yeah,
you do it,
That's how it
I
should
like
be
it.
from,
If-
but it's not showing.
Yeah, if that's the way you do it,
Mhm.
I'm good with
How
that.
did Uber
Let's
get
do the
her
next.
answer?
Hmm?
How did she get her answer?
She on the end of whole numbers, she just does this.
But it's in our
So you
brain.
already know where the
No, yeah.
decimal is, you know where to
Mhm.
start.
Mhm.
So you know where to start.
No, that's just gonna continue.
Okay,
Because-
go ahead. Go ahead and work that one out. You forgetting the rest of our numbers.
I was wondering about that. What do you do with the rest of the
You
numbers?
keep, you hold on to them.
Oh, okay. 3 and what?
5, 4.
Oh,
7.35.
that's this one I forgot.
Okay.
Okay, so you never forget these.
Yeah, don't take any numbers out. Don't take any numbers out.
1, 2, 3.
Mm-hmm. Bang, bang, there we go, there we go.
I just wanna know, it's been a long time since, you've been in school for this, but.
No doubt, that's cause usually, I'm gonna give you an example, last year, I kinda assumed that everybody knew how to do this, and so I kinda just breezed through this, until we had the first test, and everybody, the day before the test, everybody was like, hey, can you show me how to do this? And I was like, oh my goodness, I can't skip over scientific notation, cause I understand we haven't been to school in a while. But go ahead, ask your question.
Is there a rule? If the, like, we're talking about nanos and billions here. So, since I saw.
In the
there was a
metric system?
In the metric system, yes. Since I saw that it was a -9, so that's the reason why I moved the decimals, but however, now listening to Uber, is there a better way that I could have gotten that answer? Like adding zeros, like she did, and moving the zeros to one side, and if it's negative, moving it to the right side? Cause I just saw,
Hold on, you can bring that back for me,
Yeah,
I'm mixed up in that question.
for example, Lauren just moved the decimals to the left to get her 7.354. That's a positive 10 to the third. That's a 10 to the third power, which is positive. So now I got a negative number, which is a -9. So now I had to move it to the right 9 times to get that answer, 5.6. Do you see that?
So
Can you come right in, cause I don't, just in your words, I'm sorry, I'm not comprehending.
So move to the left.
You mean like putting it back in standard formation, in standard format?
Not just standard formula, but just to solve a problem like this. Okay, like here we're looking for a +3.
I don't know what I'm looking for until I do it.
But we know that as far as homework goes. As far as homework goes. And it was initially a positive number, a greater number. So we add 2 zeros. Let's add 2 zeros to the back. It would help us, which will make it easier. I can move, boom, boom, boom,
Yeah, that's what she
to
said.
get that.
That's what she said, that's what she said, so
Yeah,
you'll
that's,
know,
but
you'll know what
somebody
the
didn't
decimal.
know.
Yeah, that's what I'm saying, that's how they.
That's what I mean, if I make assumption that everybody knows how to, if that makes it easy for you to add zeros so you know what a decimal is, then that's fine. I always as a, I guess know to start at the end of the whole number. If it's a number greater than 10, I'm just gonna start at the end of that whole number. Okay? Because I can't make a whole number smaller than what it is.
And Khan Academy here has videos on how to do this, because a lot of people
Sure,
get,
sure.
a lot of people get confused on how this
Yeah,
comes out.
if you guys have different ways to do those problems, that's fine with me, as long as we're acquiring the same answer. You know, that's all that matters. And you have a way? You do it in a particular way?
No,
This the way I understand it, guys, and that's why I'm teaching it this way. But I definitely don't mind, you know, people inputting their opinion on how to do it different ways, because, you know, when we get to the metric system, that people learn it differently. People learn it differently, especially people that, you know, grew up using the metric system. Like for instance, like Jasmine, my senior student, you know, she showed me